today's data-driven environment, effective data management is essential for supporting business operation. Different database systems are designed to store and manage data efficiently. Based on organizational need, business transactions such as purchase order require accurate and well-structured data storage. A well-designed database helps ensure data consistency, reduce redundancy, and support efficient information processing. Therefore, this project focuses on designing a database for purchase order management system. Many organizations still manage purchase order record using manual documentation or spreadsheet-based system. While this method can work for small-scale operation, they often lead to a problem such as data redundancy, inconsistent record, and calculation error when the number of transactions increases. Repeated storage of vendor and item information also cause data anomalies and make data maintenance difficult. To overcome this issue, a structured data approach is required. Therefore, this project focuses on designing a relation base of purchase order management system to improve data accuracy, consistency, and overall efficiency.
My name is Saifah Attar and I will explain the ERD. This ERD shows how the database is structured and how the data in the system are related to each other. In this ERD, the main entities are company, vendor, PO header, PO details, product, and shipping. These entities work together to manage the purchase order process. The first entity is company. This entity stores information about the company that placed the purchase order. The attributes include company ID, company name, address, city, stage, phone, fax, and website. The primary key is company ID, which uniquely identifies each company. Next is the vendor entity. This entity stores information about the supplier who provide products. The primary key is vendor ID, and others attributes include vendor name, contact address, and number phone. The PO header entity represents the purchase order information. It contains details such as PO ID, PO number, PO date, and also foreign key like company ID, vendor ID, and ship ID. The primary key is PO ID, and this table connects the company, vendor, and shipping information. The PO details entity stores the detailed items in each purchase order. It includes attributes such as quantity, total, PO ID, and item number. The primary key is detail ID, while PO ID and item number are foreign key. The product entity stores information about the product that can be ordered. It includes items number as the primary key, description, and unit price. The shipping entity stores shipping information such as recipient's name, address, city, and phone number. The primary key for this entity is ship ID. For the relationship, company to PO header, a company can place many purchase order, but each purchase order belongs to only one company. For vendor to PO header, a vendor can supply many purchase order, but each purchase order is supplied by only one vendor. For PO header to PO detail, each purchase order can contain many order detail, but each order detail belongs to only one purchase order. For PO details to product, each order detail refers to only one product, but a product can appear in many order detail. For PO header to shipping, each purchase order is shipped to one shipping address, and each shipping record is linked to one purchase order.
Hello everyone, my name is Laila Yasmin. My metric number is 297209. Now I will explain in details how a purchase order database is normalized from a normalized form to third normal form by clearly identifying primary keys, assigning foreign keys, and removing incorrect dependencies to achieve a proper relations database design. Okay, let's begin with a normalized form. At this stage, all information related to a purchase order is stored together in one dataset. If we look at the structure, one purchase order contains general order informations, vendor details, shipping details, and multiple items. Because the multiple items are grouped under the same purchase order, there is no unique identifier for each item. This means item information is repeated, and the data is still mixed without a clear separations of roles or dependencies. Next, we move to the first normal form. So, in this step, we start by identifying the main identity of the purchase order using PO details as the primary key. This key uniquely identifies each purchase order. Item information is then separated to that each item appears it on record. This item records reference POID as a foreign key, which shows which purchase order that item belongs to. At this stage, repeating items group are removed and every attribute contains only one single value, making the data automatic. After that, we move into the second normal form. Okay, in this stage, the focus is on removing the focus in this stage, removing partial dependencies. Although POID identifies a purchase order, not all attributes are fully dependent on it. For example, product details. Okay, product details do not depend on POID, but on the product itself depend on POID. Therefore, the product data is separated and identified using item number as the primary key. Similarly, vendor information is identified using vendor ID. Company information use company ID, and shipping information use ship ID. The purchase order now stores this identifies as a foreign key. This ensures that each non-key attribute depends fully on its own primary key rather than partial on POID. Finally, the database reached third normal form. So in this stage, we remove transitive dependencies. Some attributes are still indirectly depend on the primary key through other non-key attributes. For example, combined locations data such as a city, states, and zip code is split into separated attributes. This ensures that each attribute depends directly on its respective primary key and not one another non-key attributes. At this point, all entities are clearly defined with their own identities, and relationship between them are properly maintained using foreign key. So in the conclusion, normalized from UNF to three normal form is a systematic process of identifying correct primary keys such as POID, item number, vendor ID, company ID, and ship ID, assigning foreign keys to represent relationship, and removing partial and transitive dependencies. This result in a well-structured, consistent, and efficient database is that suitable for real-world applications. Thank you, that's all for me.
Assalamualaikum and salam sejahtera. My name is Muhammad Izzuddin, my metric number 293493. Today I will present the table diagram for the purchase order system showing the table structure and relationship between the entity. First, the main entity is that first company that store buyer company information. The primary key is company ID. The second is that vendor that store supplier information. The primary key is vendor ID. And the third main entity is shipping that store shipping detail. The primary key is ship ID. These three tables have a one-to-many relationship with PO header. A single PO is associated with one company, one vendor, and one shipper record. But each company, vendor, or shipper can have multiple PO. Next, PO header is the central table for purchase order. The primary key is PO ID, the foreign key company ID, vendor ID, and ship ID. The purpose is to store PO information such as number, date, company, vendor, and the shipping detail. This table acts as a hub connection, the main entity in the system. Then we have a product, which store product information. The primary key is item number. PO detail store the item in each purchase order. The primary key is DT ID. The foreign key is PO ID from PO header, and item number from product table. This one-to-one relationship. One PO can contain multiple items, and one product can appear in multiple PO. Overall, the table diagram: company, vendor, shipping to PO header to PO detail, PO detail to product. One-to-many relationship from main entity to PO header, and from PO header to PO detail. Each table has a unique primary key and foreign key to define relationship. This ensures that data is well structured, avoid duplication, and follow the normalization. Also, I forget to mention this table diagram after the normalization. In conclusion, this table diagram illustrates the structure of purchase order database, how entity related to each other, and how data is managed efficiently. As you can see, the table diagram, they have their own as we can see at the table diagram, they have their own variable character. As we can see, for company ID, the company ID is varchar, company name is integer, company address varchar 100. All of this diagram have their own varchar to easily for PHP admin. Now we explain more detail about the relationship in the diagram. First, company to PO header. The type of relationship is one-to-many. One company can issue many purchase order. Each PO header is linked to only the one company. This represents the real-world scenario where company can have multiple order over time, but each order belongs to only the company. The purpose is that to ensure that every PO has a valid company and avoid duplicate company data in order table. The second relationship is vendor to PO header. The type is one-to-many. One vendor can supply good for many purchase order. Each purchase order in PO header reference exactly one vendor through vendor ID. This model, the business relationship where supply can fulfill multiple order from different company. The purpose of this to track which vendor fulfill which order and maintain supply integrity. The third relationship is that shipping to PO header. The type is one-to-many. One shipping record, shipping method or receipt can be linked to many purchase order. Each PO has one shipping assignment defined by ship ID. The purpose is that to ensure all the purchase order are associated with valid ship information, facility, logistic tracking. The fourth, PO header to PO detail, one-to-many. One purchase order can contain multiple items. Each record in PO detail correspond to exactly one PO header identified by PO ID. The purpose is that model the real world fact that single order can include multiple product, which each line item recording quantity and line total. The first is that product to PO detail, one-to-many. One product can appear in multiple purchase order detail. Each line in PO detail correspond to exactly one product linked via item number. The purpose is that to track which product are being ordered across different order, avoid duplication of product detail, and ensure that data consistency. So in summary, that this relationship ensure that the data is normalized, avoid redundancy, and maintain referral integrity. Now we will continue to my PHP. After explaining the diagram, I will now show how the design is implemented in the PHP by admin. The class diagram is translated into actual database table, memory key, and foreign key using my SQL. First, this database store all table related to the purchase order system and follow a normalization structure up to third normal form. Based on the class diagram, we have six table we create in PHP by admin. This table are company, vendor, shipping, product, PO header, and PO detail. Each table directly represent one class from the class diagram. Okay, the first table, company, we will look the structure. As we can see, we have 9 entity. The company ID is primary key. The type, all of this type of is varchar. The second table is that we look at the second table, PO detail table. As we can see, the detail ID become a primary key, PO ID if foreign key, item number, foreign key, quantity, integer, and total double. As we can see here, there are 5 entity in here. Now we look at the PO header, the second table, the third table, and the structure for this PO header, PO ID become a primary key, integer, PO number, varchar, PO date is date, company ID is foreign key, vendor ID also foreign key, ship ID also foreign key, subtotal and total amount is double. Now the table for product structure, item number is primary key, varchar, description, varchar, unit price double. For the shipping table on the structure, you can see ship ID is primary key, receive name, ship name, ship address, ship city, zip, and ship home is varchar. Now we look at the last one, the last table, the structure. Vendor ID is primary key, varchar, vendor name, vendor contact, vendor address, vendor city, vendor state, vendor zip, vendor form, and vendor format is all varchar. PO header. We go to PO header. I will explain a little bit about the PO header as the main transaction table. PO header is it store purchase order or information such as PO number, date, and total amount. This table include foreign key reference, as we can see company, vendor, and shipping, which enforce one-to-many relationship. Now the other important is that PO detail. The other important table is PO detail. Is associate or junction table. It resolve many-to-many relationship between PO header and product. This table store quantity and line total for each product in specific purchase or order. To verify a relationship, we can use designer in my PHP. We can visualize, verify the relationship between table, the connection line, confirm the primary and foreign key are correlated, implemented. Now we go to the designer. As we can see, PO header. First, we must susun dulu. Okay, as we can see, all the line is connected. This is the confirmation of primary and foreign key are correlated, implemented. This confirm that database structures successfully implemented the class diagram and maintain data integrity. In conclusion, the PHP structure accurately reflect the class diagram design and support normalization relational database system. Thank you. That's all for our group.